And taking a look at number 5, consider the differential equation dy dx equals x to the 4th y minus 2. On the axes provided, sketch a slope field for the given differential equation at the 12 points indicated. So let's take a look. My suggestion for just 12 points would be at least start putting in some points. And you can even make a table, really. I guess if you go something like what is x, what is y, and then multiply them together. So, and this would get, it would get kind of lengthy. I think you'll kind of see after a few points what you could do, but if we start all the way over here, you're never going to get it wrong. That point is -1, 0. So if I put a -1 in here and square it, I get 1. If I put a 0 in here, I get -2. So my slope there is going to be -2. So I'll grab my blue, get some -2 slope going on there. Go back. Let's go here next. -1, 1. So -1, or 1 times -1 will give me -1. So my slope should be getting shallower, less steep, I guess you could say. If I put in -1, 2, I'm going to have 1 times 0. If I put in -1, 3, I'm going to have 1 times 1. So let's put those last two in. Slope of 0 and a slope of 1. Looking good there. Now I'm going to start just saying the words. If I put in 0, 0, I'm going to have, actually if I put in any 0 for x, which would be all these points, those are all going to be 0 slopes. And then if I put in the same values, basically because I squared it, these slopes should be exactly the same. This slope should match this slope. This should be a slope of 1. Again, a slope of 0 and a slope of 1. So I think the big points would be make sure these match and all the zeros. While the slope field in part A is only drawn at the 12 points, it is defined at every point in the xy plane. Describe all points in the xy plane for which the slopes are negative. So we had a couple different negative slopes here and here, and we had some positive slopes up there. So when would the slopes be negative? And if we look at our function, or our slope function, we basically want to know when will this be less than 0. So x cannot be 0, because if x is 0, the whole thing equals 0, which would make it not 0. So basically it's just y minus 2 less than 0. So when is y less than 2? When y is less than 2 and x doesn't equal 0, the slopes will be negative. A little algebra problem. Alright, and then the one we've been waiting for. Find the particular solution of y equals f of x to the given differential equation with the initial condition of f of 0 equals 0. Remember, that comes in later. We're going to use that to solve for c. So the first thing that we want to do is, just get rid of that. We want to separate the variables. We want to get everything with the x's over here, everything with the y's on the other side. So our only option is divide by the y minus 2, dy over y minus 2 equals x to the 4th dx. Great. And start integrating. The integral of dy over y minus 2 is going to be our classic natural log of y minus 2. Our integral of x to the fourth is just x to the fifth over 5. And then, of course, our plus c. Now, we want to try to get this pretty simplified before we look for our initial condition. So our move is take both sides with that e power. E to the natural log, the y minus 2 gets to come down, equals e to the x over 5, x to the fifth over 5, plus c up here. That e to the c becomes, I'm going to go ahead and keep writing up here, absolute value of y minus 2 equals c e to the x to the fifth over 5. When we show that, we can lose the absolute value because it will be, we can basically put a plus or minus here. So it's like y minus 2 equals plus or minus c e to the x to the fifth over 5. C can be positive or c can be negative, so we can absorb it. So y equals c e to the x over to the fifth over 5. Now I can put in our initial condition. Y is 0 when x is 0. C times 1 equals 0, therefore c equals 0. I know what you're thinking. I just traveled back in time. Mr. Richard forgot to add the 2 over. So now when I put the initial condition of 0 in, I get c e to the 0 plus 2. I subtract the 2 over. E to the 0 is 1. Therefore c is negative 2. You were right. I might have got something wrong. And we're done. Y equals negative 2 e to the x over 5, x to the fifth over 5 plus 2 would solve our differential equation with the initial condition of f of 0 equals 0. Go calc.